Hi, I'm Martin Lindsay from the Studying Learning Centre at RMIT University. This is a short movie on indices. Let's start by looking at what we mean by a base and an index. Here we have 2 to the power of 3. In other words, the 2 is the base, the 3 is the index or the power. Notice also that students tend to confuse this with the same as 2 times 3, which it is not. 2 to the power of 3 means 2 multiplied by itself 3 times. In other words, 2 times 2 times 2, which gives us an answer of 8. Let's look at some examples. X to the power of 4. Well, x is the base, 4 is the index. So it's x multiplied by itself 4 times, x times x times x times x. Here we have a squared times b to the power of 5. Notice here that there are 2 different bases, a and b. So multiplying them out, a squared is a times a, and b to the power of 5 is b times b times b times b times b. Finally, we have 4 times m cubed times n cubed. So we leave the 4 alone and we multiply out the m 3 times, m times m times m, and the n is multiplied out 3 times as well, n times n times n. Again, the bases are different. We'll now go through some laws of indices. Here's the first law of indices, which says that x to the power of a times x to the power of b is the same as x to the power of a plus b. Notice here that the base must be the same, but also that when we multiply terms with indices, we actually add the indices. Let's do an example to illustrate this. We have a squared times a to the 5. So using the law, that's the same as a to the 2 plus 5. Notice here the base is the same, so we can add the indices 2 plus 5. So the answer is a to the 7. Similarly with numbers, 3 squared times 3 cubed. The base is the same, which means that we can add the indices 3 to the 2 plus 3, which is 3 to the 5. 3 to the 5 gives us an answer of 243. And finally, here's a problem where we have a number and a fractional index, 4 times x to the half times x to the half. So we leave the 4 alone, the base is the same, so we can add the indices, a half plus a half, which is 1. So we have 4x to the 1. Notice another important thing here is that x to the power of 1 is exactly the same as just x. So we can leave our answer as 4x. Now let's look at the second law of indices. X to the a divided by x to the b is the same as x to the a minus b. A couple of things to notice here. The bases must be the same. And when the bases are the same and we're dividing terms, we subtract the indices. So for example, a to the 5 divided by a to the 2, the base is the same, therefore we can subtract the indices. 5 take away 2 is a cubed. Similarly, with numbers, 2 to the 7 divided by 2 to the 4, the bases are the same, therefore we can subtract the indices. 2 to the 7 minus 4 is 2 to the 3, which is 2 times 2 times 2, which gives us an answer of 8. And finally, here are two numbers, 10 and 5. 10 to the x to the 11 divided by 5x to the 6. Here we can divide the numbers. 10 divided by 5 gives us 2. That's one part of this problem. The other part is dividing the terms with indices. X to the 11 divided by x to the 6. The bases are the same, therefore we can subtract the indices. So it's x to the 11 minus 6, which gives us 5. In other words, our answer is 2x to the 5. The third law of indices says that x to the power of 0 is equal to 1. Now notice that any base with a power of 0 would always give us an answer of 1. Let's look at the reason behind this. Let's look at this problem, a cubed divided by a cubed. If I do this the long way, I've got the fraction as shown, a times a times a on the top, a times a times a on the bottom. Notice they all cancel, giving us an answer of 1. But there's a quicker way of doing this, using this law. A cubed divided by a cubed, same base, therefore we can subtract the indices. 3 minus 3 is 0. That gives us a to the power of 0. And the third law says that anything with a power of 0 to it gives us an answer of 1. Now let's look at the fourth law of indices. Notice here that we have brackets with an index inside and an index outside. So when we have this situation, we multiply the indices. We don't add them, we multiply them. So here, x to the a, all inside brackets, with an index of b outside of the brackets, gives us an answer of x to the a times b. So for example, 4 cubed, in brackets, to the power of 2 would give us 4 times 4 times 4, multiplied by 4 times 4 times 4. This is the long way of doing this, which gives us an answer of 4 to the 6. But if we use the law, we multiply out the indices. In other words, 4 cubed to the power of 2 is 4 to the 3 times 2, which is 4 to the 6. As you can see, a much quicker way of working out this problem. Notice also, when we have a fraction as a base, we do exactly the same as before. In other words, the numerator is 4, the denominator is 5, so they both get index. In other words, 4 cubed divided by 5 cubed. And that gives us 4 times 4 times 4, which is 64, divided by 5 times 5 times 5, which is 125. So remember, with a fraction, you use both the numerator and the denominator will have the base to it. Finally, let's look at square roots and cube roots as indices. Notice a couple of things here, that the index inside the root is the numerator of our new index, and the index outside the root is the denominator of our new index. Let's illustrate this with an example. Here we have the square root of x, which is the same as x to the power of 1 inside the square root, and we could put a 2 outside the square root as well. And using the rule above, that will give us an answer of x to the 1 over 2, or x to the half. So the square root of x is the same as x to the half. Similarly, here we have the cube root of x squared. So the square is on the top of our new index, the cube root is on the bottom of our new index. So that gives us an answer of x to the 2 over 3, or x to the 2/3. Now try some problems for yourself. The answers to these questions are on the next slide. Thanks for watching this short movie.